So before we get started, let's see what is involved in setting up an RHCE target and initiator. So in RHCE is an extension to the SCSI protocol. Traditional SCSI uses a long cable and a SCSI command descriptor block command to attach to SCSI devices. In RHCE we are using the same CDB commands but encapsulated in IP packets that are sent over a network. And in RHCE the SCSI devices are emulated by using a storage backend and presenting it on the network using RHCE targets. So what you will be doing is you will be creating some storage, which can be a partition or a logical volume, and you will share them over the network using the RHCE target. In RHCE you also need a network. That can be an Ethernet infrastructure. These can be as fast as fiber channel structures, which is another SAN solution. And that makes RHCE an enterprise-ready choice to create a SAN. So in RHCE, what we've got is on the bottom a SAN. On the SAN we have a process which is the RHCE target. And the RHCE target gives access to the storage backend. And then there's a server that wants to connect to the SAN. In order to do that, the server runs the RHCE initiator, which is also a process that you will be starting on your server. And from the RHCE initiator, you need to do a discovery. The discovery is going to talk to the SAN to find out what exactly is offered. And once the RHCE devices have been discovered, the RHCE initiator can do a login to the devices. So different components are involved. First, there's the target on the SAN that gives access to the storage backends. These storage backends are something that you need to set up yourself as well, as we will see in the demo that will follow this presentation. The backend can be a complete disk. It can be a dedicated partition. It can be a logical volume. It can even be a file, as long as it's a big empty file that you can export as a storage device. So in RHCE we need servers to connect to these using the RHCE initiator. And after successful connection, the connected server will see the newly added storage devices. On the RHCE initiator you can check that in the proc partitions file, which gives you an overview of all partition and storage devices that are currently known to a server, or by using the RHCSA tool, which is not installed by default, by the way, but it's available in the repositories, so it's easy to use it. Before starting your work with RHCE, it's good to have a good notion of the terminology that is used. So first there's the IQN, which is the RHCE qualified name. That's a unique name that is used for identifying targets as well as initiators. It is important to set the IQN because it can be used in security. Then there's the initiator. The initiator is the RHCE client that is identified by its IQN. We have the target, which is a service on an RHCE server, that is the SAN that gives access to the backend storage devices. And you can work with ACLs. ACLs are access control lists that are based on the node's IQNs. And then there's the notion of a portal. A portal is the IP address and port that the target or initiator uses to establish connections. It is also referred to as a node. We will see this node part when using with the RHCE ADM command on the RHCE initiator. There's discovery, which is the process where an initiator finds the targets that are configured on a portal. So you can have more than one portal on one server, you can have more than one target on one portal. And there's the LUN, which is the logical unit, the block devices that are shared through the target. Then there's the process of logging in. Logging in is the authentication that gives the initiator access to LUNs. And there is TPG, which is the target portal group, which is a collection of IP addresses and TCP ports to which a specific RHCE target will listen. It is important that you know this terminology even before going to the exam, because the tool that you'll be using for setting up RHCE uses this terminology. And if you don't know this terminology, well, you don't know what the tool is expecting from you. So after connecting from the RHCE initiator to the target, the RHCE initiator will see added block devices as local devices, such as dev SDB, dev SDC, and so on. And if a LUN is exposed to multiple servers will have access to the device after connecting to the LUN. Which is like if you connect a hard disk to different servers, at the same time. That is kind of cool, but also kind of dangerous. So if you want to create a configuration like that, you normally would need clustering to provide access to the device, just to make sure that it can never happen that two servers are writing to the same file system at the same time. Because if you try to do that on an XFS or an ext4 file system, well, it's not really made to do that. As an alternative, you could also consider using a shared file system like GFS2. In GFS2, the file system cache is shared between the nodes, which means that all nodes writing to the file system are aware of what the other node is doing. But both clustering and GFS are not part of the RHCE objectives, so we won't talk about that in here.